All right, 1.1, Introduction to the Practice of Statistics. So in this section, we're going to cover these 5 objectives. So we'll be going through those objectives as we go. All right, so our first objective is to define statistics and statistical thinking. So statistics is the science of collecting, organizing, summarizing, and analyzing information to draw a conclusion or answer questions. So all of those things have to happen in order for it to fall into statistics. We do bits and pieces, but we really need to bring it all together. We need to collect it, organize it, summarize it, and analyze it to finish off the full statistics circle. All right. Now, things that we are looking for there are information that is done within statistics is referred to as data. These are fact or proposition used to draw a conclusion. They describe characteristics of an individual. A key aspect is that data in data is that it varies. Not everybody has the same height or the same hair color. So different things vary within those. And things from day to day, how much you sleep every hour, how much you eat every day, things like that also vary. So we want to be looking at those things and how do they affect our statistics. All right, so objective 2, explain the process. So first of all, we need to break it down here. We have 3 things. We have a population, we have an individual, and we have a sample. Now, population is everybody we want to look at, whether we're looking at just our college or whether we're looking at the United States, whether we're looking at the world, any of those things, we need to define our population. Now, an individual is any single item out of those populations, whether, again, you talk about people or whether you talk about things, stuff like that. It's going to be a single object out of that. Now, a sample is a small group out of the population. So, for instance, if we were looking at the college and we wanted to break it down by age, each age group would be a sample within that population. We could also go into male and female and those types of things with that. So those could be samples. But it can be a mix of things. Doesn't have to be a certain group. It can just be that we picked 100 people out of the college to get our sample to be able to do our statistics on. A statistic is a numerical summary based on a sample. So when we talk about the word statistic, it means it's based on a sample. Descriptive statistics consist of organizing and summarizing data. So we're going to be looking at those types of things. Inferential statistics uses methods to take results from a sample and extend it to a population. So when we infer something, we look at our sample and we bring that to our population. And then a parameter is a summary of the population. So you want to make sure you can pay attention to those 2 words, the difference between a statistic and a parameter. Statistic goes to sample, they both start with S's. Parameter goes to population, they both start with P's. All right, so here's some examples. So 48.2% of all students on the campus own a car. So this number would represent a parameter because we're talking about all students on our campus. Our population is the students on campus. So since it's at all of them, then that is a parameter for the population. Whereas if we did a sample of 100 students and find that 46% own a car, that is a statistic because we only looked at 100 students out of all of them on the campus. So that is a statistic because we did a sample. All right, now the process of statistics is a few parts. We got to do a few different things. So let's go through those. So first, we want to identify the research objective. So we got to determine what questions do we want answered with that, and also identify the population so that we know what we're studying. Second, we need to collect the data needed to answer those questions that we had there at the beginning. So we want to make sure that we're collecting the data for those things. Now we go and describe the data, doing descriptive statistics and things like that so that we can start dealing with that data. And then finally, we want to perform an inference. We want to go, hey, what does this data tell me? And then I can extend to the full population and all of those things. And so we're going to look at how to do those throughout this semester. All right, so just kind of an example of this process. So here we have a research group called Pew Research, and they conducted a poll and asked, do you trust all or most of your neighbors? And so let's look at the process to conduct our study. All right, so our research objective, the researchers wanted to determine the percentage of adults who trust all or most of their neighbors. So the population here is our adult Americans. So we have our population, adult Americans, and then our question is, do you trust all or most of your neighbors? And what percentage of adults fall within that? Okay. So now we need to collect data. All right, so they go out and they survey here. It looks like they tried to get a few. It's impossible to do everybody in America because then A, they're not going to answer them, but B, there's just way too much information and too hard to collect all of that and sort through it. So they surveyed a sample of adults, and they ended up being able to survey 1,628. Of those, 847 stated that they trust all or most of their neighbors. So they were able to go and take a survey using a sample here and get information from that survey. So once we've got that information, we need to describe the data. So of those individuals surveyed, 52%, and they got that 52% by taking 847 divided by 1,628. Okay, and so 52% stated they trust all or most of their neighbors. So there's our descriptive statistic taken from the data. And then finally, we look at an inference here. And so they wanted to extend the results to all Americans. So we generalize this. And so they feel pretty confident that a percentage of all Americans who trust their neighbors is somewhere between 49.5 and 54.5. Now again, we'll talk about margin of error and all those. They got these other numbers from later on, but they were able to make an inference there with a pretty good certainty by the end of their process. All right, objective 3, looking at qualitative and quantitative variables. All right, so variables are the characteristics of the individuals within the population. So we can have different ones there. Like I said before, your gender, male, female, age, 20s, 30s, 40s, color, all those different things. When we talk about people, we could be talking about dogs and they get the same thing within those, or whatever we want to talk about. There are going to be variables within the population. All right, and variables vary. So that's always going to be one of those things. We just want to know how to get the best from those things. All right, so qualitative, also known as categorical variables, allow for classification based on attributes. So like I said there, gender, male, female is kind of the easy one to go to on that. And so we have those pieces. If we can put it into a category, a named category, then we are going to call it qualitative. Quantitative is when we have numbers to measure. So like age, their 20s, 30s, 25, those things, breaking them down, weight, those types of things with them. Okay, so just kind of an example here. Again, gender is qualitative. We've done that one a few times. Temperature, those are numbers that we can move around and categorize to those numbers. A number of days that a student studied. So number of days there, we can add those up, so that's quantitative. Now zip code's a little tricky. We think of zip codes as numbers, but they are actually locations with those, okay? And so they are qualitative because we are talking about those. We don't add zip codes together, whereas we can add the number of days, we can add the temperature, but we don't add zip codes together. And so they are a location, so that's why they're qualitative. So you got to be careful with some of those types of things. Sometimes there are some numbers that we use that are qualitative that we need to make sure that we're careful with, and zip code is one of those. All right, now discrete and continuous. So discrete is a quantitative. Now both of these are quantitative. Qualitative is all about being able to put a label on it. So for instance, again, male and female, those types of things, black and white, those types of, where it's a name. Quantitative is numbers. Well, discrete means that we can count those numbers. So like the number of people, we count them, 1, 2, 3, with those. And there's typically an endpoint on the number of people on those. Whereas continuous has an infinite number of possible values with those. Now that's something that could go forever, but it could also mean that we could have fractions of things. So time, there are milliseconds upon milliseconds that we can't count, meaning an infinite number of things. And so those are continuous. All right? So again, here we can break things down. Qualitative is by itself, but quantitative can be broken down into discrete and continuous. All right, so let's look at these. Are they discrete or continuous? We know they're quantitative. So the number of heads when flipping a coin 5 times. Well, that's discrete. There's no half of a head, any of those things. There's not an infinite amount. It is 5 times how many heads? The number of cars in a McDonald's drive-thru, again, is discrete on this one because you can't have half a car that's actually going to drive through the McDonald's. They're all individual cars, and it's a set time frame, so it's not an infinite amount there on that. Now, distance, this one is continuous. Now, we would think, oh, it's always going to be between, but those numbers are always going to have different decimals, and the more precise we get, the more that we can put in there. And that's an infinite number. So anytime that we can break something down into these small decimals that can go very close together, those are continuous. So distance, height, time, weights, different things like that are going to be continuous. The list of observations, a variable assumed is called data with those. Okay, so again, qualitative data, we have it goes with the qualitative variable. So data just talks about the variables. So all of those things are the same when we deal with them. So those words, data just is going with those variable on that. Okay, so here's another example. We want to be able to identify individuals, variables, and data from the table here. So we have our countries, we have the type of government they have, the life expectancy, and then the population of those countries within those. And so there's a lot of different things there from those, okay? So first, the individuals are the countries. So Australia, Canada, France, Morocco, Poland, Senegal, United States. Okay, so we have all those pieces there. Variables are all the other pieces, the government type, the life expectancy, the population. All of those things have their own pieces. Now, government is qualitative because it tells me what type. We go back and look, it has words, whereas life expectancy and population have numbers, so those are quantitative, okay? Now, the life expectancy is continuous because of how it's measured. It's life, it's a time, so time is always going to be continuous on those things. It's an average of things. Now, population is discrete. That's always counting people. There's a set number of people within each one of those. There's not an infinite amount. There are not decimals of people within those things, okay? Now, on these other pieces, it was an average, but technically they would, it's a rounded, it's a rounded, not an average, whereas life expectancy is an average on those things, okay? So be careful with that. All right, and then the observations are the data, and so we could match those things up if we needed to. All right, objective 5, level of measurement. So we have 4 different types of measurements when we're looking at a variable. So let's look at the different ways to describe them. The first way is nominal, and that means that we just can put a name to it. Again, the easiest one to think of here is male and female. So it doesn't follow anything else. It's just, hey, we can name these things. The second one is ordinal. It means we can put them in order. So for instance, vice president and president, they have an order. In a race, you have first, second, and third. We can put those things in order. Interval means that we can block things off in an interval. So they may go from, say, 20 to 30, things like that when we're looking at those pieces. And then ratio means that we can compare things, this per something, those types of things. And so we have a ratio. All right, so let's look at some examples of these. So again, I use this one over and over. Gender is nominal because it is only male and female there. And so we can just have names. Even if you go outside the box and a little more, have the other types of genders, they're still just names. It doesn't matter what they are, okay? Temperature is interval. We can say it's in the 30s, it's in the 40s, it's in the 90s down here in Southeast Texas, sorry, with that. So we usually talk of things in intervals there. The number of days a college student studied during a week is a ratio. So it's the number of days per week with those. So that's that ratio type. Okay. And then the letter grade is ordinal. We talk about A's versus B's versus C's. And A is better than a B, which is better than a C, and so forth with those things. Okay. So we can break all those pieces down and talk about that description. All right, so those are the things that you're going to need here for 1.1, looking at all those definitions to see what's happening.